Okay, good morning, good afternoon, good evening, wherever you are. I'm Steve Garetta, Director of Product Marketing at Rigado, and I'm happy to be the host and moderator of today's webinar with our friends at Klika-Tech. And the topic today is all about multi-beacon commercial solutions and IoT using AWS Greengrass. And I'm going to introduce our presenters and bring them in shortly. First, we have Justin Rigling, our Chief Technology Officer at Rigado. And we have Michael Vadalou, who is our Solution Architect from Klika-Tech. Welcome, guys. Thanks for being here. And as always, if you have a question, please submit via the Zoom Q&A panel. We're going to start jumping into questions at the end of the short presentation today. So feel free to drop them in there, and we'll get to as many as we can. And with that, let's go ahead and kick off the presentation. So first, we're going to talk about each company in brief. First, I want to introduce Rigado. In case you're not familiar, Rigado is an enterprise IoT data solution provider. We specialize in commercial spaces. We've been here for just about 10 years now, with many thousands, hundreds of thousands of gateways deployed globally, specializing in logistics, smart office and buildings, connected and retail. Our platform provides enterprise Bluetooth connectivity and applications. We have partners in a number of different areas, Klika-Tech being one of them, and we're going to learn more about them today. And our solutions are deployed by some of the largest service providers across those different verticals that bring edge data connectivity and edge computing for end user customer value and applications. And Rigado really is a platform that brings things like data collection, sensors, monitoring to the cloud. And that's really what today's topic is going to focus on, is how we bring cloud connectivity. So there's edge infrastructure, which is how do I collect and process data locally? And then there's bringing that to the cloud. How do I create an enterprise IoT application out of that for use cases such as asset tracking, cold chain, occupancy, and predictive maintenance? And so there's a variety of commercial spaces that Rigado's technology gets applied to. We're going to look at a couple of examples today. And the solution partners really help us bring that to market. And that's where we're going to bring in Klika-Tech and learn what they're doing in the IoT space. So with that, I'd like to introduce Michael, and Michael's going to tell us about Klika-Tech.
Thank you, Stevie. Hello, everyone. Michael is on the line. So the Klika-Tech is the global developer IoT, cloud, and big data solutions developer. We work with the startups, mid-level enterprises, and Fortune 500 companies to develop best-in-class projects and innovate hardware, firmware, and cloud solutions. Our team of more than 170 people provide deep expertise in IoT and cloud product development, including hardware prototyping, firmware development, cloud architecture, and mobile applications. We partner with customers to form a deeply integrated team that together can co-create a solution and bridge the gaps between IoT concepts and market-ready products and services. We work with companies across a dynamic range of IoT-intensive industries, including smart home, smart building, smart city platforms, connected healthcare, connected retail, connected agriculture, smart mobility, global logistics, asset tracking, and intelligent vehicles. As Amazon Web Services Advanced Consulting Partner, our expertise is differentiated with AWS Service Delivery Program designations, including AWS IoT Core, AWS Lambda, Amazon API Gateway, and AWS CloudFormation. The project we're exploring today is the perfect example how Klika-Tech works with industry-leading innovators like Rigado to provide technology, services, experiences, and ultimately experience that enables us to be our customers' collaborative development partner. From the design state through the project engineering, development, deployment, and ultimately ongoing support, we work together with customers to reach a shared goal of delivering the high possible ROI. Thank you, Stevie.
Okay, so thanks for the introduction there, Michael. And at this point, what I want to do is start to dive a little bit deeper into the solutions. And now I'm going to bring in Justin to talk about the uh, edge solution that we have at Rigado and how that relates to IoT commercial spaces.
Thanks, Steve. So I want to introduce the Rigado IoT Edge solution as really a mechanism to collect data from BLE devices and send that data up into cloud applications. We really service three kinds or categories of BLE devices. The first one here are BLE beacons. With BLE beacons, we're typically collecting advertisements. We've really focused on the scanning abilities of our Cascade gateways. So we've been able to scan over 20,000 unique devices in a few minutes or process nearly 1,000 to 1,200 advertisements per second. So really focusing on performance there. Also on range so that you can install fewer of these devices and have great coverage area. We've done some experiments in line of sight conditions with over 500 feet of range. So very good performance there. The way that this advertising collection usually works is that the Cascade gateway will filter that and format it into something like a JSON blob and then send that up into the cloud applications via MQTT or HTTP or some of those standard protocols. Now, we've got also other types of devices. So we've also got more complicated sensors that send data as advertisements, but might also need to be connected and for something like a configuration of a threshold, adjust a sampling interval for temperature, something that requires a little bit more connection logic to happen. Our Edge solution, which is software called Edge Connect, also handles those kind of use cases. And what we've learned over the years is that hundreds of customers have looked at Cascade as a place to deploy custom applications like an app on a cell phone. But because embedded development is a bit different and there's a few struggles to get through, we've done a lot of work to characterize those common workflows. So things like listening for an advertisement, doing a connection, reading from a characteristic, and then closing the connection. Those common workflows are all supported out of the box with Cascade and our Edge Connect software, so that instead of our customers needing to deploy code to these gateways, there is a simple configuration that enables these very common workflows. With Rigado maintaining all of that Edge software, our customers don't have to worry about yet another code base to monitor or maintain or look for security fixes. The third type of device that we commonly support is something that needs a bit more interaction than just these simpler sensors. So something like a temperature logger for compliance in food safety or pharmaceuticals will often hold data for days or weeks. And so when it comes in range of the gateway, it needs to be able to have a bit more interaction to pull all that data off and send it to the clouds. So we support devices like that as well, using these common workflows and a few more that we've added over time. Now, while supporting all three of these types of devices, we have to make sure that the infrastructure itself is managed. So we have an Edge Direct platform that focuses on making sure those devices are taken care of while they're in the field. It supports the provisioning, remotely deploying things like certificates and keys, and keeping those security patches up to date on all these devices. This is what the Edge solution looks like, but let's take a look at how it's used in an actual use case. In this example, we're looking at an asset tag, which includes some sensor data that is being sent to the Rigado Cascade device, really being collected as an advertisement. And then from that Cascade device, messages are being sent over MQTT into one of the major cloud providers, where then an alert can be created for a mobile user. There are a couple different ways that we often see this solution implemented. And so for a simpler use case, the data that's coming from that asset beacon can just be forwarded directly to the cloud resources, and then the cloud resources can do the logic. For a more complicated version, that edge processing of what logic to do or the decision making can actually be performed at the edge. And for situations like that, that's where we work really closely with our partners at Klika-Tech to kind of extend the capabilities of Cascade up from the cloud.
Yeah, and I think that's a perfect time to bring Michael back in. And before I have Michael dive into these, we did a case study with Klika-Tech that Klika-Tech is now published on their website. We'll provide information later on where to go get that, but it really illustrates the work that they do on these more sophisticated use cases. So Michael, why don't you take us through a couple of those scenarios?
Thank you, Steve. Actually, I'll take it from here. The use case below actually is the part of the case study published on the websites of Klika-Tech and Rigado. And we would like to share our experience and example how the computing and decision-making could be delivered from the edge, from the cloud to the edge. So as Justin mentioned before, we have a beacon. And in our case, this beacon advertises temperature data. This data collected by the onboard BMD 345 radio chip, which is built on the gateway and provide to us a possibility to catch advertisement packets. Management of this radio module is handled by Edge Connect Snap because the gateway runs Ubuntu Core and has snaps installed on the board. And one of them is Edge Connect, and it's cover the radio control and provide the functionality of the pipelines we just mentioned before. So during this scenario, in a straightforward and simple implementation could be the following. We just get the gateway, set up the Edge Connect pipelines, and redirect all the scans result from the specific beacon to the cloud, to the AWS IoT Core. And actually on that side, the all data, the all raw scans cached by IoT rule, which are already set up and trigger the action. And this action triggered the Lambda. And this Lambda make a decision about how we should notify our clients using the SNS service. And the advantage of this solution, actually, this is quite straightforward and simple. But why do we need the edge computing here? First of all, it makes sense to save the traffic and not the produce messages and the data which is not needed for us. The second reason could be that we don't pay for the storage or additional computing each time the gateway publishes a message. And the third thing, maybe we want to handle connectivity loss situations. So to solve this issue, there could be several ways how to handle this. For instance, we can use the snaps. This option provided by the Edge Direct service, and we can deploy. We can build and deploy our own snap, which will handle the situation somehow. But we'll need to put additional effort to do this, and it will cost time. In this case, Greengrass can help us. So why Greengrass? Greengrass actually is the software which provided by AWS, and recently Canonical put it into the Snap and make it available on Ubuntu Core platform. The Greengrass has native integration with all AWS services, and actually this is the reason why it saves a lot of time using all this tool. It's allow easily scale and deploy the new features, and it can provide machine learning interface on the edge. And in the future, nearest future, it become the industry standard. We think so. So and this use case would be refactor it a little bit in the following way. So as before, we have a beacon which reflects temperature data and data collected by the radio on the gateway, and Edge Connect pipeline send all data to the AWS IoT Greengrass core endpoint, local endpoint, which provides also MQTT endpoint. The raw data, raw scans comes to the Notify Lambda, and actually this Lambda using the machine learning model, which is trained for decision making on the edge and pre-installed on this gateway before. This Lambda make a decision: should we notify cloud or not? In case if we need to do this, it's publish a message in the notification topic, which has deployed a rule for the redirecting and sending the data and sending a message to the SMS. Also, in case of alert, in case of connectivity loss, this Lambda can set the alert on the gateway in the solitary state, for instance. And alert messages handled by rule and send the notification to the SMS. And coming back to the edge, the raw scans data consumed by another Lambda, which is called backup Lambda. And this Lambda stores the scan result in the local file storage, for instance, files. Once the gateway has reliable and wide internet connection, for instance, Ethernet or Wi-Fi or so on, the third Lambda, and actually it's long-running Lambda, which is called cloud-to-cloud Lambda, can detect this and upload these files to the S3 bucket. On the cloud side, the SageMaker service will grab the whole files or the whole scans results from this bucket and train the new model, machine learning model. And this machine learning will be transparently delivered to the gateway. So this is the example of how the whole cycle works. And actually, this cycle allows to scale the solution and adopt it for any needs.
Thank you, Michael. I want to ask one follow-up question on this, and I'll direct it towards Justin. So as this type of a design gets deployed, as the solution changes, how does that get managed? And is that easy to do? Do you update the snap? Is it all done in the cloud? What typically happens there?
Yeah, for a scenario like this picture, there can be updates to many different parts of this solution, which is why delivering IoT solutions is often very complicated. So, Michael could probably explain a little better, but if it's an update to the Lambdas that are deployed, those updates are going to be deployed via AWS and the tooling that AWS provides for that. Now, if the update is actually a security update for Greengrass, and just yesterday there was a libNSS vulnerability discovered and announced, and so we're in the process of making sure we have an updated version of the Greengrass snap with that vulnerability patched. So that can actually be deployed through the Edge Direct platform for making sure these devices are always up to date. And then the same thing can happen for our Edge Connect snap for security updates and features. But if for example, you want to add a new type of sensor that may or may not need slightly different configuration into the Edge Connect pipeline, which can be completely managed through Edge Direct.
Mm-hmm. Okay, great. So one thing I want to refer back to is the case study that Klika-Tech put together, which describes some of the benefits from a business and project position on the scenarios we just reviewed. So you can see more about that at Klika-Tech's website, download the case study. It's really interesting to see how you can deploy an edge infrastructure on something like Cascade with Edge Connect, but also work with a company like Klika-Tech to really customize it for the type of use cases and devices that you're going to be deploying in that type of customer environment. I think we'll have a couple of questions here at the Q&A around that. So certainly go check that out when you have a moment. And with that, I actually want to start getting into some of the Q&A here and open up the conversation a little bit. So if you're a participant on want to submit a question, go ahead and do that in the Zoom panel. We'll try to get to all of them. One question, which I'll send this over to you, Michael, is we've talked a lot about AWS Greengrass, but certainly the Rigado platform and Klika-Tech's work is not limited to AWS. What might this look like in, say, an Azure or another type of cloud application? Is this all applicable? Are there similar technologies involved? What does that look like?
So thank you for the question, Stevie. Actually, in the Klika, we use the tools, which is good for and actually the best match for the specific use case. And you're right that we're working with the different clouds and can implement the different solutions. In this specific use case, which was described before, we mentioned Greengrass because the main feature of this, it allows save a lot of time. Actually, in case if we use the applications based on AWS, not only on the edge, but in the cloud. And these two things together can save a lot of time and allows people goes to market easy. But you're right that, for instance, if our clients already has applications which is based, for instance, on the Azure or some other clouds, or they don't need actually that, or it's a custom case, and we will select the tools according from the requirements.
Okay.
Thank you.
Yeah, great. And some other good questions here. One around security. Justin, I know this is a topic near and dear to your heart. How are the Bluetooth endpoints secured, and what considerations there go into the design?
Yeah, this is one of my favorite areas, actually. So I'll start by saying we care about security not just in Bluetooth, but also in the infrastructure itself. So the devices have secure boot and encrypted file systems, key management. So when the certificates and keys are there to connect to your cloud or connect to your devices, they're protected from attackers ripping those devices off the wall and trying to open them up. So that's a very important first step. Regarding connectivity over Bluetooth, there are a couple different strategies that we've worked with customers to enable. One of those strategies is to, of course, have Bluetooth LE security or Bluetooth 4.1 or Bluetooth 4.2 security, where the pass keys are used and unique per device. And in that situation, the Edge Connect software can make a request to the AWS IoT Core. There could be some Lambdas involved to actually retrieve the appropriate unique pass key for whichever device you need to connect to. We've also seen worked with customers on situations where there isn't actually Bluetooth security, so the connection itself is not encrypted, but there is effectively end-to-end security, which can relax some of the requirements for things like devices that roam around between different devices, lowers the connect time because of like pairing or bonding procedures, but does have a couple other advantages and disadvantages. So lots of different opportunities for security there. And whenever we work with a customer, we make sure that we fit whatever their use case is.
Yeah, so that's an interesting last point there, and I was going to throw out this additional question, which is we have a lot of participants on the line. They may be starting a project or trying to put together a solution. We've talked here about a lot of real deep technical things that we have created along with Klika-Tech to make all this work really seamlessly. What's the best way to get started? I think a lot of folks don't know that your role as Chief Technology Officer also includes heading up solutions at Rigado. So what are the things you like to talk about when someone first reaches out at a project, and how do we decide where to go from there in the project?
Yeah, the process usually is best started with a conversation. Talk about the use case. Talk about how the end devices are designed. Are we looking at a project where there's an existing mobile application that basically the functionality from the mobile application needs to be translated into the infrastructure that's going to be in the fixed infrastructure in the buildings, or is this kind of a new device that has firmware that's being developed at the same time? And we can talk through that and look at the use cases. One of the things that really helps us in helping discuss what the right path forward is to draw sequence diagrams of how the device will advertise, when the gateway will do a connection, what data is sent back and forth to which characteristics. So looking through all those things, it can be pretty straightforward for us to make a recommendation of how to proceed. And in most cases, even do a small project where we can build the very first configuration as a reference for you to take over and maintain over time. And that way we can get a really quick start for you.
Great, thanks. And for those participants that might have joined a little late, we'll post the whole recording of the webinar, which includes all the diagrams and also the links to the case study we mentioned. I want to thank both Justin and Michael for joining, and we've got their email here in case you want to reach out with additional questions. And always feel free to connect with Rigado if you have an IoT project you want to discuss. And with that, thanks again for all the participants for joining, for Justin and Michael, and have a great rest of your day.